Have you ever heard someone say, gravity isn't real, it's just a theory? Let's explore this. Hello there, welcome back to Star Stuff, where we try to explain things simply, even for people who really find it difficult to understand science. In science, theory doesn't mean guesswork. It's a well-tested, evidence-backed framework that explains and predicts how nature works. Gravity isn't just a theory. It's one of the most reliable foundations of modern science. And without it, we couldn't understand Earth, space, or, quite honestly, anything around us. Let's start simple. Weight. Your weight is the force of gravity pulling on your mass. The equation is weight equals mass times gravity. Your mass is how much stuff you're made of, and gravity, that little g, is what turns it into a force. If gravity weren't real, you'd have no weight. Airplanes couldn't calculate lift, bridges couldn't be engineered to hold cars, and scales at the grocery store would be totally useless. Everything that relies on measuring or resisting force would collapse. Literally. Now take atmospheric pressure. The air above us has weight, and gravity is what gives it that weight. At sea level, the air is pressing down on you with about 14 pounds of force per square inch, all because gravity pulls the atmosphere towards Earth's surface. That's why we can predict how pressure changes with altitude. It's why weather systems exist. It's even why you need pressurized cabins in airplanes. No gravity equals no atmosphere. No atmosphere equals no breathing, no climate, no life. Next is buoyancy. Archimedes figured out that an object in a fluid experiences an upward force equal to the weight of the fluid it displaces.
It was Archimedes that explained that buoyancy is an upward force that's exerted by a fluid against an object. If the object's heavier than the fluid, the object will sink. In this case, gravity is actually forcing the brick down through the particles of the water. There is still an upward buoyant force, but it's just not enough to lift this brick. Now, since the styrofoam weighs less than water, it floats. If I submerge it, the buoyant force will push it up through the water because buoyant force is actually greater than the weight of the styrofoam.
Notice that word again, weight. If gravity didn't exist, there'd be no such thing as heavier and lighter fluids. Ships wouldn't float, hot air balloons wouldn't rise, and submarines wouldn't work. Entire industries, shipping, aviation, even your rubber duck in the bathtub, all make sense because gravity exists. And here's an everyday tool you've probably used yourself. A spirit level. That bubble inside the liquid, it works because gravity pulls the liquid down and the bubble floats upward. Without gravity, the bubble wouldn't know which way is up. Builders couldn't construct walls, carpenters couldn't align surfaces, and even hanging a picture frame would be guesswork. Next time someone claims gravity isn't real, ask them how they plan to hang a shelf without it. But gravity isn't just local. It explains tides, caused by the pull of the moon and the sun.
The strength of the moon's gravity is strongest at A because it's closest to the moon. So the part of the ocean that bulges towards the moon most is at A. But the moon's gravity also pulls on the Earth, moving it towards the moon as well. Lastly, the far side ocean at sea is also attracted to the moon. But it moves least because the moon's gravitational pull here is at its weakest, being farthest from the moon. Now we can see why, when the Earth rotates through 24 hours, it goes through 2 high tides and 2 low tides.
Predicting tides is crucial for navigation, fishing, and even renewable energy. Without gravity, the oceans would never slosh the way they do. What about orbits? Satellites, the moon, even the Earth itself moving around the sun. All of it only works because of gravity. If it weren't real, GPS wouldn't function, weather satellites wouldn't exist, and we'd have no International Space Station. Here's where things get even more important. Gravity is also the reason we know the Earth is round. What? On a flat Earth, gravity would have to pull sideways at impossible angles. But that's not what we observe. Instead, gravity pulls everything to Earth's center. That's why oceans stay level all around the globe, and why people in Australia don't fall off into space. In fact, gravity is what shaped Earth into a sphere in the first place. Once a planet gets massive enough, gravity pulls evenly in all directions, smoothing it into a round shape.
Now you could ask the question, how much matter do I need for gravity to get strong enough to start overcoming the strength of rock and sculpting things into spheres? Well, that minimum size has got a name. It's a brilliant name. It's called the potato radius. You can see why, because things that are too small for gravity to be strong enough to sculpt them look like misshapen potatoes. The great thing is you don't even need to imagine it. You can calculate it. I did that this morning and I got an answer, just roughly between 100 and 200 kilometres. The brilliant thing, the most beautiful thing, was if you look up into space and look at the moons of Mars and Saturn and Jupiter and objects out there in the solar system, you'll find that, roughly speaking, if their radius is bigger than about 200 kilometres, they're beautiful spheres. And if the radius is less than about 200 kilometres, they look more like misshapen potatoes.
Understanding gravity isn't just about dropping apples. It's about understanding the very structure of planets, stars, and galaxies. Every time we design something new, from skyscrapers to rockets, we calculate forces, pressures, and trajectories using gravity. If gravity weren't real, the maths wouldn't add up. Engineers wouldn't be able to build planes, astronauts wouldn't be able to dock spacecraft, and you wouldn't even be able to bounce a basketball. So no, gravity isn't just a theory. It's the backbone of physics. The reason we can do calculations, build technology, and explore the universe. Without gravity, nothing in science or engineering would make sense. With gravity, we can predict, invent, and expand our understanding of the cosmos. Next time someone shrugs and says, "Gravity's just a theory," you can smile and say, yeah, the kind of theory that makes the modern world possible. Because gravity doesn't just keep us on the ground, it keeps science grounded too. Thank you so very much for watching. Please like and subscribe and share it with anyone who is struggling to understand this theory of gravity.
Do it. 5, 4, 3, 2, do it.
Please keep learning. Cool beans.